That is the most important part. How we have to select that beam, column. Okay.
Sir, if you are free at 2 p.m., can you take daily at 2 p.m.?
Yes.
Etabs class, can you take at 2 p.m., sir?
Delhi.
Are you free? Yeah,
Yes, we can do that.
yeah, because 11 at morning I have some work, so we do it. So,
Okay, so you do that the class 1 p.m. that is the Revit and 2 p.m. Etabs. No issue.
for continuation class, we will be easy to take.
Yes, Munir, you comfortable?
I told the brother, Mr. Sonar, I want to check with the management because they want to start a new course for me. So I will check the time. If in the morning,
Okay.
it's okay. I think by Sunday or Monday, I will let you know. Because until now, they didn't arrange the time for me.
Okay,
Okay.
no issue. After that, otherwise, if you have a time, then we can
Yeah,
join with
no
2
problem.
p.m.
Yeah, no
Okay.
problem.
Okay, so this is the selections tool. Okay, so here are the basically what are the building, what are the components exist there. That is the first one. That is the joint, right?
Yeah.
Okay. Another one that is the beam. Okay, and the third one that is the column. Okay. So there are two cases for that. If I select by using that the window, okay, by using that the window, you see that all the components are selected there, right?
Right.
That is the joint also selected, columns also selected, and beam also selected. And it only selected that the one story because here I have selected one
Once.
story, right? But in case suppose that on a single story, if we have to select that only beam, only the column, only the joint, the slab, the wall, like that, then how can we select? Okay, so for that we have to use that the selections tool. So go to the option select command. Okay, there is a command that is the select, deselect, and invert selection. Okay, so for the select, if you want to go in the select, then go to the options object type. Okay, object
Yeah.
type. Okay, after that, when I using that the object type command, so here it will be the one story or all story and whatever command you have taken there. Okay, so it not depends on that. Okay, when I select that the joint from there, it means that when I click on the option select, so you see that it select all the complete joint of the building, right?
Right.
Either it will be
Yeah.
the one story or all story, never mind. Okay, same like that, if you want to remove this the selections, then you have to click options deselect. Okay, so see that all the joints will be deselect from there. Now the next one, that is the column. So just click on the option select, so automatically it select all the columns of our building, right? And for
Right.
the deselections, you have to click deselect. Now the next one, for the same case for the beam. Okay, selections and deselections, but it select that the complete structure. Now if we have to select that only one story, then what we have to do, we have to just select one story there, and by using that the window select complete structure. After that you have to suppose select that the beam, then joint and columns use deselect. You see that only the beam has been selected there, yes or no, right, of a single story. Same like that, if I have selected all the complete structure and we have to only select that the column, then just go on the option select deselect object type. Okay, that is the joint deselect and beam deselect. So here remains that is the only column. Okay.
Okay. Can we do that for all story?
Yes.
Can we do this for all stories in the
Yes.
bottom?
Yes, if you want to do for the all story, okay. So go in the option, select object type, okay, and click on the options column directly. So it selected all the story.
Okay.
Okay,
Right. Right.
fine. Now the next one, same the options deselect will be automatically open. Okay, so when you are using that the select and deselect, both command will be working as a similar properties. Okay, so when you are using that the deselections and go in the object type, you see that same window will highlight. Yes or no? Suppose we have to deselect that the column. Okay, so just click on the options deselect. Right? If you want to select that the beam, the joint. Okay, fine. So like that you can select or deselect working at the same one. Next one, that is the invert selection. So you see that when I have selected that the joint and the beams, okay, so it deselect the joint and beams and select all the columns. So that is the invert selections. It select that the opposite property that is not selected. Okay.
Again, Mr. Sona.
Hmm?
Again, the inverse selection.
Suppose I have selected only the columns, right? Okay, see that
Okay.
the selections is the column only here, and if I want to use the invert selections, it means that the joint and beam selected. Okay, only invert selection, you see that it only selected that the joint and beams.
Okay, without the column.
Yes, so it deselect that the column and it select that the joint and which, that is the beam.
Yeah.
So understood that the selections to method, yes or no?
Yeah.
Yeah.
Right. Now the next one, that how we have to apply that the point load on a beam and UDL on a beam. Okay. So for that you have to first add that the point load. Okay. And UDL. So if you want to add the point load and UDL, you have to go in the options define. Okay. And in the define, use that load patterns. Okay. What we have to do? We
The
have to
button.
use load patterns, and here we have to select for any dead load. If you want to apply, then we have to select the type that is the super dead. Okay.
So what is
Yes,
the
no.
difference between them, sir? Dead and super dead.
Dead is basically the self weight of the structure. Okay, I already told in the first of the class ki in Etabs we don't have to provide that the self weight of a structure, it is already included. So this is the dead load, that is the self weight of a structure, it is considered automatically. And if we have to define that the point load, UTL, whatever the load, if that is the wall load, okay, whatever the load, if we want to provide that, we have to select that the type super dead here. Okay.
Okay.
Now after that, just here write that the point load. Okay, and then click on the options add new load. The next one, that is the UDL. Okay, what is the full form of UDL?
Uniformly
Uniform
distributed.
dead load.
Uniformly distributed load, not dead load. Okay.
Yeah.
Yes, uniformly distributed load. And what is the full form of UVL? UVL.
Uniformly varying load.
Hmm. Uniformly varying load. So in
Varying
here,
load.
yes, varying load, it means that at every point the load will vary, that is called uniformly varying load. Okay, now I add this two load. Then next we have to just click on the options. Okay, after that, if we have to assign this point load and UDL, so we have to go in the options assign. Okay, in the assign, go and use that the command that is the frame load. Okay, in the frame load there is a load given that point load, and another one that is given that distributed. So click on the options point load. Okay, select that the load pattern name, that is the point load. Okay, load pattern name, that is the point load, and here we have to apply that the point load at a distance, at which distance you want to specify, and what is the load of point load. Okay, So now if you want to use that the absolute distance from end first, we have to apply it from absolute distance from end first. Okay, fine.
Why we select the second option?
Basically, if you have learned that the AutoCAD, so there are
Yeah.
basically three types of coordinate system you have learned, right?
Yeah.
Which one? Can you specify the name? What are the
Polar.
three coordinate system we have used? Yes, Muni, you just tell me.
X, Y, Z.
That is the coordinate system. I just asked coordinate system. What are the name of
Coordinate
coordinates?
system.
Have you learned that absolute coordinate system, that is the rectangular coordinate system? Yes or no in AutoCAD?
Maybe yes, but I maybe forgot.
Relative coordinate system, the another one that is the relative coordinate system, and the third one that is the polar coordinate system. So there are basically three types of coordinate system available in CAD. And same like that, if we are using for the distance purpose, okay, so we use only two coordinate system, that is the absolute, it means that rectangular, okay, and another one that is the relative. So when we are using that the absolute coordinate system, it means that it specify the total distance from the origin, okay, it calculates all the
Mhm.
distance from its origin. But if we are using that the relative distance, it means that at every point we change, at every point of coordinate we specify that origin, okay, the origin will be not at a fixed point,
Right.
okay, it will be
I
vary at
think
a point to
always
point.
will be used the absolute distance. Huh?
Yeah, basically in most of the, apart from the CAD, in the CAD relative distance is better, okay, if we have to
Yeah.
go for the coordinate system. But in the every software we have to use that the absolute coordinate system, because we have to fix that the coordinate from where we have to specify all the distance. So here this is the origin, right, that is the
Right.
x y z. So we have to use that the absolute, it means that this origin will be fixed at a position, we can't move this origin to the every point, yes or no,
Yeah.
right, in our software. So that's why we have to use that working with absolute distance, okay, right.
Okay.
Any
Okay.
query? Okay, now so here I have selected that the load pattern, and the next one that is the load type and direction. So what we applied, that is the force, okay,
Yeah.
Mhm.
and in the Etabs already the gravity load are available, so we have to select gravity load, okay,
I
fine.
think we not mention the minus symbol.
No, in that case we have to note so that any specific value in that is the load in the minus, okay, that is the in the negative value we have to specify, because gravity load is available, so we have to assign all the value in the positive form,
Yeah. Okay.
okay, right. Now, and the most important part, that is the option. Here given that options, so there are three types of options. The first one, that is the add to existing load, another one replace existing load, and third one, that is the delete existing load. So you already know that what is the meaning of delete existing load. It means that we have to only delete the load that exists only, okay, that I have applied, okay. So what is the difference between add and replace? So suppose that I have applied that the 2 kilonewton of point load on a structure, right? But
Mhm.
it is not the correct load. I have made the mistake, and we have to apply that the 3 kilonewton, okay? So we can just use that the replace existing load. So when you replace the existing load, so 2 kilonewton load will be override on the 3 kilonewton, okay? So this is the replace existing load. It means that I have replaced that the previous load that I have applied. Okay, fine.
Okay. These, like Mr. Son, these 2 kilonewton. You
Yes.
mean you apply it like this window when you click on absolute distance and you add 2 kilonewton. Again, you open this command and you add 3 kilonewton, right?
Yes, we can replace by the 3 kilonewton. Okay,
Okay.
fine. Next one, that is
Okay.
the add existing load. Suppose I have used that the replace existing load. Okay, right, okay, and I
Yeah.
have applied that the 2 kilonewton, but we have to apply that the 3 kilonewton. So if you want to not replace the load, then you can go in the add existing load and you can add 1 kilonewton more. Okay,
Right.
right? So understood
Yeah.
what is the add or existing load? Add or replace existing load,
Yeah.
right? So now here I just apply that at a distance of 1.5 meter, right? Okay, at a distance of 1.5 meter, we apply that the 2 kilonewton load of point load. Okay, right? And now we have to just click on the options apply, but here it shows that the message no selected objects were found in the receive the assignment. So in that case we have to apply that the load on the beam, but I have not selected the beam. Yes or no?
Right.
Yeah.
Right, so we have to just go in the options select command, that is the object type, and select all the beams from there, right? Yes or no?
Yeah.
Now
Right.
after that we have to apply, then it will be properly applied, then click OK. But the load are not visible on the 3D view.
Right.
Fine. So what we have to do, just click on the options 3D view, and if the load is not visible, then we have to go in the command, which one? That is the display.
Display.
Yes, display
Load the signs
and load assign, and we have to use frame, because we have applied that the point
on
load
the beam.
on the frame, that is the beam, right? So click on the frame. Here you have to select that the load pattern name, which one? Point
Okay.
load,
Right.
and then apply, and then okay, you see that the load is visible on the 3D view.
Right.
Yes or no? Fine.
Fine. So, Mr.
So
Sonam, when you add 1.5 meter, it's measured from the origin, right?
yes, it started from the origin. You have seen when I applied that the load, right? When
Right.
I apply that the load, so you see that it asks that absolute distance from the end first.
Okay.
Okay, so you see that this is the plan view. So this is the,
Right.
I have assigned that the beam from that side. So it this is the 1.5 meter, right? 1.5
Yeah.
meter. So you see that from the all side it is taken that 1.5 meter. Okay,
Okay.
clear?
Yeah. Clear. So this method is called absolutely.
Yes, this method is called absolute. And if we have to vary that, then we have to use that the relative.
Can you select the relative to see what's the difference?
Relative is not useful in the applied that the load. That's why.
Okay.
Okay,
Okay.
it will only applied where we have to vary the load. Okay, right? Yes or no?
Right.
That is in the cycling load.
Mm-hmm.
But here we have to not apply the cycling load, we have to apply that the point load UDL, because on the structure this type of load are act. Okay, when we applied that the point load, it means that the load acting in the form of axial load. Yes or no? That is on
Right.
the column, you can apply that point load is the another example of axial load. And what is the
Right.
UDL? When we apply that the load of wall on the beam, so it is acting on the form of which, that is the UDL. Yes or no? At the
Okay.
everywhere load is same.
Right.
Fine. So that's why. Okay, so you have to use only absolute, not go for the relative. Okay, so that's
Okay.
why I mentions in the starting of the page. Okay, I explained that the coordinate system for that only.
Right.
Okay, now the next one we have to apply that, which one? That is the
UDL
UDL. So for the UDL, just go in the assign again,
joint.
then frame load, then that is the distributed. Okay, now load pattern name we have to select,
UDL.
that is the UDL. Okay, right? So same here the options will be given, so we are using that the replace existing load, and now we have to apply that all the UDL on the beam. So select beam, here is the options, that is the uniform load. Yes or no?
Right.
Yeah.
How
Uniform
many?
load, so we apply that the 3 kilonewton per meter of UDL, then apply, and
Absolute.
okay. No, in that case, we don't go for the absolute. We have to not use this load. We have to use only this one load. Okay,
Okay. 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 Right.
right?
Second.
And then click OK. So now you see that this is the 3 kilonewton of UDL are applied on the structures. Okay, but in that case point load is not visible. So again, if we have to see that the point load and UDL, then you can go for the display, right? And another one that you see that this is the backward arrow and the forward arrow, right? So if you click on the forward arrow, okay, or backward arrow, the load will change from there. Here it is written that the UDL. Okay, when I click on this arrow, so you see that this is the dead load, that is the self weight. Okay, now the next one, that is the live. So we have not applied any live load, right? Now the next one, that is the point load, and this one, that is the UDL. Okay, so understood that how we have to apply it.
Yeah.
Now the next, we have to apply that the load combinations of dead load. So if we have to create that the combinations factor for dead and live, okay, or only for the dead, we are using that the factor value, that is the 1.5. What is the combinations factor we have to use? 1.5. So just go in the options define, okay, and click load combinations. Load combination. Okay, load combinations. Here we have to use that add new combo. Add new combo. And specify that the name, that is the combination load. Okay, right? Now here we have to first add the self weight, that is the factor value 1.5. The scale factor will be 1.5. The next one, we have to click on the options add, change that the load name, that is the point load, scale factor, that is the 1.5, and next one, that is the UDL, and here scale factor 1.5, and then click OK, and then this is the combinations load. Again, if you want to visualize that combination load, then click on the options modify / show combo. Okay, so you see that again it is, you can check that from there, then click OK, right? Yes or no?
Yeah.
Now after that, we have to go in the options analyze, click on the check model. Okay, click on the check model, and here this is used for checking that any problems or any defect in our model. Okay, that is the if the joint is overlapping to each other. Okay, if there is
Or
frame
failures
overlapping to each
opening.
other, all that we have to check. So you have to directly click on the options select or deselect all. Okay, so when you click that, it is selected. When you again click, it is deselected. Okay,
So
so we
select
have
all
to
of them,
select
right?
all. Yes, select all. Okay, and then click OK. So it check that your model and specify that if any problems. Now it shows that a message, yes or no?
Right.
What is the message it is given that?
There is no any warning
Warning.
messages.
Yes,
Like
it means that the
errors in
model.
Staad.
Yes. In a stat, it specifies that the errors, right?
Right.
But Etabs is the benefit that here it not show any error. It only shows that the warning message if you have a mistake. But you can check your output file, okay? But instead, if the error will be applicable or specified in your project, it means that you can't open that your output file.
Yes.
Right? So here it shows that the message model has been checked. No warning message were generated. It means that our model will be very clear. Okay. No any problems in our and defects in our model. Okay.
Yeah, Mr. Sona, what's the difference between Etabs and Staad
Yes.
in the modeling when we check the model?
In the Staad and Etabs.
Yeah.
The Staad is not used for the modeling part. Okay.
Oh.
It's only for analyze.
Stat is only used for the analysis and design, but Etabs used for the modeling purpose also. So that is the main difference between the Stat and Etabs.
Okay. Okay. Can we have a report right now after we have checked the model?
Yes, we can check that the report of shear force, bending moment, axial force, all that we can check out that.
Okay.
Okay.
So now our building it's passed the design, right?
Yes, you have to just study that the result. Okay.
Right.
And what we have to check in our model, that where the maximum shear force applied. Okay, you have to only check that members ki where the maximum shear force applied and where the maximum bending moment applied. So building a design for the purpose of maximum shear force and maximum bending moment.
Yeah.
Okay, so you have to check that result and you have to study that report. Okay, when you study the reports you get all these calculations. Okay, all these things. Yes or no?
Right.
Now, after that, again, we have to go in the options, analyze, and click on the options, run analysis. Okay, so I have sent that the syllabus of Etabs to you or not?
Yeah.
No.
Okay, so I sent that Etabs syllabus to you also. Okay, so now
So
it
I
is
think
analyzing that the structure. Okay,
right. It takes a quite long time or a few minutes.
yes, it takes that a few minutes. All depends on the structure. Okay, and
Okay.
the load you have applied. Okay. So now I just cut one window and I only display you 3D. You see this is the deflected shape. Yes or no?
Yeah.
That is the displacement. Okay. And what is the maximum displacement? It is showing that maximum displacement and minimum displacement. Yes or no?
Yeah.
Right? Okay, now if you want to see that the animations, okay, of deflections result, if you want to check that the animations of deflections result, so you have to click on the options start animation. Okay, the building will deflected vertically in the vertical directions. Yes or no?
Yeah.
Hmm? Because we have
Yeah.
applied that the vertical load, so the building will deflect in the vertical directions.
Yeah.
Now stop the animations, and if we have to check that the deform undeformed shape and the results, all these things we have to go in the options display. You have to note it down. Okay, all the results we have to check in which, that is the dis display option. Okay, click on the options if you want to see that the undeformed shape, so you have to click that. So now it is undeformed shape. Yes or no? Right?
Yeah.
Again the building in the starting of the phase. Now if you want to see that the deformed shape, so just click over there. So with the various types of load, that is the self weight, point load, and UDL, we can check that the deformed shape. So first one, that is by the self weight. So this is the deformed shape by the self weight, right? Okay, if you want to see that the wire shadow also. Okay, now the next one by the point load, how it is deflected. You see that? Yes or no? This
Yeah.
is the deflected shape by the point load, and the another one, that is the by the UDL. You see that? Yes, right?
Yeah.
Now if you want to check by the combinations load, so this is the combo load and I apply. So this is the deflected shape by the combinations, and after that I apply. Okay, now in that case, if I check by the combinations, so you see that the maximum displacement and minimum displacement value has been changed. Yes or no?
Yeah. It's getting high.
Yes. And if you want to see that the maximum displacement and minimum displacement by the different kinds of load, so you can just go and click there. Okay, so this is the combinations load. Right now this is the combinations load. Again we have to just change that. This is the self weight. It changes into the self weight. Next one, it will not change from there, so we have to change from there. Okay, so you can check that the displacement results, right? Fine.
So
Or
what
any
about the
query?
bending moments and shear forces?
I will go for that also. Okay, so now next one, if we have to check that the shear force, bending moment, axial force, all these things, so for that we have to go on the options force stress diagram. Where we have to go? Force stress diagram. And for that you have to go in the options frame oblique pier. Okay, oblique splendor oblique link forces. Now we have to check by the point load, that is the axial force. Click on the axial force, then apply. You see that this is the axial force diagram. So you know that what is the properties of axial force? When we apply that the axial force, it means that it increases into the downward directions. Okay, right?
Okay.
And it applies that the same properties, yes or no? It increase in the downward directions, right?
Yeah.
Okay, and if you want to see with value, then you have to just click on the option show value. Okay, then apply. So now you see that the value of all this data, yes or no? Right?
Right.
Okay, now the next one, that is the shear force. Okay, if you want to check that the shear force, then apply. Okay, so this is the shear force result. Okay, fine. And if we have to see that the moment, bending moment, so you have to click on the moment 33, then apply.
So what is meaning of 2232?
I already explained that when we have to assign that the column, okay, that is the second direction space and third direction space, yes or no?
Yes.
Yes or
Yeah. Right.
right? Yes. So this is the bending moment by the point load. If we have to check that by the UDL, so it will be so that in the parabolic, yes or no? What is the shape of bending moment by using that the UDL? That is the parabolic shape, and you see that all the shape are in the parabolic form, yes or no?
Yeah.
Right? If we
The
have to,
point load in linear, right?
yes, point load will be go on the upper side and downward side. That is the plus x and minus x. So like that you can see that the bending moment. Okay, right? And if you want to check that the result into the detail view, so just right click on the beam and column. Okay, so you see that by using that the point load, what is the equivalent load applied there, right? That is the shear force. Okay, yes or no? Right, that is the moment, and this is the deflected shape. Fine. And if you want to see that by the UDL, so you see that it formed that the parabolic shape, yes or no?
Yeah.
Parabola, right? And all the value are given also there. Okay, fine. So any confusion in the result, yes or no?
No, but Mr. Sono, how can we get the report?
Yes, how can?
We get a full report because now it's showing in the screen only.
Yes, if we have to create
Because
that
in
if we have to create that the Excel sheet, right? So we just go in the file, that is the export table to the Excel.
okay.
Okay, so here this is the options analysis result. Okay, right?
Mhm.
So you can export from there.
For
Okay,
example, we can select a load combination.
yes, you can use that the load combinations.
Load
Okay, and
combination.
export this one. Okay, that is export in the Excel sheet. That is the desktop. Okay,
Mhm.
now if we have to see that the support reaction, that is used for which purpose? That is for the foundation design. Okay, so if
Right.
we have to see that the support reactions, so just go in the options display force stress diagram, and that is the support reactions. Okay, because we have applied that the fixed support, so three forces and three moments are applied. Okay, so I just show you in the table form, that is the force in the x directions. You see that, yes or no? Force in the x directions, force in the y directions, force in the z directions, moment in the x directions, moment in the y directions, moment in the z directions, and this will all by which? By the point load. When I change that the UDL, so you see that the result has been changed. Yes or no?
Yeah.
Right? And if we applied that the combinations load, so you see that the result has been changed.
And
Okay?
these combinations loads are used for the foundation design.
Yes, we have to apply that for the foundations design. Okay?
Okay.
That is the load in the FZ directions. Okay, that is the vertical, the summation of vertical load. So any confusion?
No, Mr. Sonal, the FZ, this is the total from the top to the bottom.
Total vertical load. Okay,
Okay.
total vertical load by the
Okay.
combinations of point load and UDL.
Right.
Okay, right? So any more query?
Now, can we see the Excel file?
Yes, I just open that. This is the Excel file. You see that this is the combinations load I have just added. Yes or no? Right?
Okay.
And this is the Etabs program control define. So same like that, you can export that all the reports. Okay.
Yeah, actually, I was looking for the result for shear force and bending moment.
Mm-hmm. Okay, now right click on that and you can check that the result there. Okay, for the shear force and bending moment. Okay.
Okay, can we export it to Excel sheet?
If there is a options of shear force, then we can export there also. Go to the
So,
table to Excel. Okay, right?
right.
Okay. And that is the load cases. Load case summary. Okay. What we have
Yeah.
to use? Load case summary. Fine. Sorry. Or either in the loads, we can just see that the here that is the options. This is the most important things. That is the applied load. Okay. I just export this one first. Okay. Right.
Okay.
And if you want to save that the
Yeah.
summary, okay, if you want to save that the summary, so just click on the options load case summary. Okay.
Yeah.
Again we have to just go in the options file, export table to Excel. That is the
Load summary.
uncheck this one. Okay, that is the analysis, load cases or load case summary, and then click OK. Okay, fine. Yes or no?
Yeah.
So like that we can save that the result and we can export the result. Okay, and another one, if you want to check that the reaction, okay, right, the reactions result. So for that we have to go in the options result. Okay, right, that is the displacement result. Yes or no? Joint displacement.
Yeah.
Okay, and this is the reaction, joint reaction. Okay, so you can export that both the options, both the table. Okay, fine.
Yeah, so many tables.
Yes, if you are doing that, the structure, it means that we have to study the results in the details. Okay,
Yeah,
the structure is not easy as like the design.
yeah.
Okay, you have to just think about that and then you have to apply.
I
Okay.
think if we try one project, then we will be like familiar with this
Yes, yes.
structural
If you do that
analysis,
the
right, Mr. Sona?
if you do that the one project by itself, okay. So you will be familiar with this project or with the software, okay, how we have to use that. Okay. And if you do that the so many number of projects, then you can be an expert
Yeah.
in structure.